So today we're going to talk about a course content, so which is nothing but called as DevOps. Okay, so myself is Raghu, and I have been working as a DevOps engineer from past 3 years almost. And prior to that, I used to work as application engineer, and even prior to that, I started working as Linux administrator. And coming to the teaching experience, I have almost 4.5 years of experience. Delivered more than 60 batches in shell scripting and Linux and AWS and also even DevOps. Okay, altogether more than 60 batches. And today we are here to learn about what is this DevOps. Okay, so you might be seeing this particular word very highly in the market. Okay, so what is this particular DevOps and where it is being used, and what is what? Just let me give you a small introduction, and then we'll end up with the course content today, a small demonstration. So I'll not take much time, so mostly like 15-20 minutes, that's all. And before going with the DevOps, okay, you need to understand that DevOps means it's not like a developer job and operation engineer job, so a single person is taking care. It's only about the collaboration, that's all. Okay, it's not like a developer is learning the ops job and ops guy is doing the development job and both is being done by a single guy. No, it's a two different teams altogether. Okay, but it's all about the collaborating between them. Now, how do you collaborate? Okay, so before going with how do we collaborate, let's try to understand what are the teams might involve in a product development cycle. Okay, the first team usually comes into the picture is development team or the developers. These guys, what they do is they develop the new product. So it can be a Java or Python or PHP, whatever it is. So usually, okay, so if you come to the DevOps environment, so the most of the applications will be on Java. So that's the reason you'll be having a Java content all the time. So I'm talking about a pure Java content over here. So whenever you talk about developers, so they usually develop a new products, new applications, and also these guys develop if there is already an existing product, so they usually work on new features, enhancing the certain functionalities, we can say. Okay, and if there are any bugs, usually these guys are usually developed. Now, so while developing this a product, there is a certain terms or a certain process involved. There are two processes which are involved, so which is a legacy process or legacy development, and other one is called as agile development. What is legacy development? Legacy development was there from pretty long time, and what is this thing is, if a company wants to make a product, they will invoke developers and make the product, test it, enhance it, come up with all the features at a time, and they release in the market. So this was happening from pretty long time. So whenever someone wants to come up with a new product, so they'll build the product, they will include all the features, whatever they want to include at a time, and they release the product. Okay, so what is going to happen over here is, so to making all the products functionality, okay, it takes 1 or 2 years. At least you make a time as 1 year. 1 year is a big amount of time where company is investing without any revenue. You don't know the product is going to click, or it is going to hit the market, or it going to fail. So we don't know that. And still for the 1 year, company is investing on that particular product. So this was the challenges actually coming up in the management side. Okay, so for the management, these are the challenges. So whether they can sell the product or they cannot sell the product. And meanwhile they are developing this particular product. Some company may come up with the same kind of product, so in between them, and that product may become famous. So your product may be losing the revenue. So you have a lot of challenges over there, and those challenges are actually addressed in agile development. What is this agile development? So agile development is the latest kind of development process usually people are following. And whenever you go with agility, what people do is whenever they think about let's say 10 features, okay, of a product, so they'll take one feature and release the product. They'll make only one feature and release the product. So once they release the project, okay, so they'll get some customers and they start getting the revenue. And once they start getting the revenue, so based on if the customers ask for a new product, or these guys have announced, okay, so a roadmap saying, okay, in this year or in this quarter of this year, we'll release this particular product or this particular functionality or this particular feature. So they'll be having a roadmap. And so based on that particular roadmap, so the customers are going to ask you certain other features, or you are going to release whatever you have committed. So like this, agility is basically, so you develop a single feature, release it, single feature, release it, single feature, release it. So day by day you may make a releases. Day by day you make releases. So that's what actually this agility is, and this is what actually the actual trend presently the developers are following. Okay, so the major thing is the company will, in the initial stage itself, they'll come to know their product is going to hit the market, or if they get any customers, and they'll start getting the revenue. So it will be easy and easier for both the ways, for the customer as well as for the management to handle this particular development. Developing the features. Now, okay, so this is what actually the development team does. Okay, so they develop the new features. Okay, if there is an existing product, or if it is a new product, so they will create the new product and come up with the new features, and they'll make those new features, and certain enhancements and functionalities will be usually comes with the new features, and also they fix the bugs, because these guys makes the product, and so these guys are responsible if there is any bug. Okay, and coming to the next team. Okay, so what is the purpose of a developer is only to develop the code and put it in a repository. So we call that as a repository. So there will be a central repository where each and every developer is going to put the code into its repository, into a central repository. Now the next team comes into the picture is a build and release team. A build and release team. Okay, so what these guys does is, okay, these guys makes the builds and release them. These guys makes the build. Okay, so whatever the code developed by the developer is a Java code. It needs to be compiled, and okay, so it has to be put it on the application servers. Okay, so this particular part, okay, making the build and releasing it to put it into the application server, these guys will take care. And usually, okay, so these guys take care of other jobs also, because build and release might be a small thing, but these guys manage little other things like code repository management. So whatever the code the developers is putting into the central repository, so that particular repository server is being usually managed by this team. There may be another team also. There can be an IT team, okay, but usually I'm saying, okay, in a DevOps environment, so usually these guys manages this one. And also while releasing, okay, so there will be a lot of versions might be, okay. So today, as I told you, as a agile development, so there will be a one version released with one feature. So in the one version there might be some enhancement is required, so they can release a 1.1, 1.2, and even 1.2 there is a small bug which was fixed in 1.2.1. All these okay, version management are usually taken care by this particular build and release team. Okay, so there are certain tools, and those tools management also usually take care of this particular team. On the left side you can see, so I have just kept a couple of tools usually these guys works, which is Git, SVN, Maven, Ant, and Jenkins and Hudson. And once the build and release engineer, okay, so makes a build, okay, so what happens is, if build was successful, then they forward this particular build to the QA team, quality team. Now in the build and release team itself, while making a build, if they face any challenges or any errors, they themselves will go back to the developer and they give this okay, so errors to them, and they fix the code accordingly and send it back to build and release team. So they mutually work together and make a build. And once the build is ready, so it goes to the QA team. And QA team, what they do is they apply a lot of test cases and check whether it is working on all the desired platforms. And finally, if everything is fine, they'll just give they'll just give a go ahead to next level. Okay, and if something fails in the test cases, okay, or in the test results, these guys will send back to developers, and again the process happens. Okay, so if there is any bugs, it goes back to developers, and again developers make the changes and again put it into repository, and build and release team make the application and again give it back to QA, and everything is good, they'll say good to go, and then it handles to the next, handles to the next team. Otherwise it is going to be to the developers again. Okay, now let's talk about the next level of team which comes into the picture. Okay, so which is application team. What is this application team does? Okay, this application team maintains the applications on a different environments like UAT, production, okay, SIT, and some kind of environments are there. Okay, so these environments, okay, so you're usually managed by your application team, and not the complete environments, only the environment with respect to the application. Okay, there are application servers like Tomcat, JBoss, Web Server, WebSphere, and WebLogic. Okay, there are 4 major application servers, and these applications are hosted in these application servers, and this application team manages that application. Okay, so even if you take a small, small product also, there will be, tens of servers, and if you talk about a medium application, there will be hundreds of servers. Okay, and if you talk about if you talk about websites like e-commerce, okay, so there will be huge number of servers, thousands and thousands of servers are hosted with applications. Okay, so these applications are usually maintained by application team, and these guys' responsibility to ensure your application is available with 100% uptime. So if something goes wrong, so who will be pointed is application team, not the developer, not the QA guy, not the build and release guy. If the website or the application is not working, okay, so who will be pointed is the application team. So these guys, okay, responsibility is to make this application available in our application have 100% uptime. Now another job these guys do is, okay, so whatever the QA guy has given the good code, okay, so if they want to put it into the production, so these guys will take care. So they'll not directly go into the production, so they'll go with the UAT, okay, user acceptance tests, and if everything is fine, so they'll on a fine day, so they are going to put it into the production. Okay, so there is a major delay happens in this particular team. Okay, why? Because there is a live application running, and these guys will not allow you to put whatever the code you have made actually every day. Okay, so to put a code, so in the legacy environment, it even takes 6 months also. Okay, so 6 months is a very big time. Okay, so today I make a feature, I want to wait, a developer has to wait, or he'll be sitting idle all the time. Okay, so till the code goes to the production. Once it goes to the production only, so user starts using it, and if there is any issue, again it goes back to the developer. Okay, so there is a lot of gap happens. So 6 months is a pretty big time. So usually, okay, at least 15-20 days is the average time. Okay, so for a release into the production in legacy environments. So there is a lot of gap in between other teams to application team over here. So these are the operation guys actually. These are the ops guys. Okay. Now there is another team also sometimes involved in the deployment process. So the other team is nothing but operating system team. So usually the companies are I can say like this. Usually, usually there will be a different operating system team. Okay, so which will not take care of application management. Okay, so application engineers are different, system engineers are completely different in a big environment, we can say. Okay, so if you take a big company, okay, if it is a small company, so if you have let's say 20-30 servers, okay, application guy can take care of take part of even the OS responsibility. There is a chance, but usually if you are talking about very huge number of servers and mid-cap companies, and the OS team is always completely different and application team is completely different, and sometimes there is a chance that okay, you're hosting your application in a cloud environment or a different data set vendors, okay, like Rackspace, so they will take care of OS responsibilities. You have to engage those guys. So where these guys will be involved is whatever the new code you are putting in, in the production requires some changes in the operating system. Then you have to engage these guys, and these guys' responsibility is obviously to manage the 100% uptime of the server. If these guys makes the 100% uptime of the server, then only the application guy can make 100% uptime of the application. So these two guys are very critical, and they will not allow you to put the changes as you think you want to put it like that. Okay, so they'll not allow you. So there's a lot of process. You have to create a Jira ticket. It has to create approved, and then okay, they'll review that. Then they will go create a change request, and then it has to get approved by all the stakeholders. So a lot of process will be there. Okay, now so on an average, actually, this was the one of the statement recently mentioned by one of the CEO, one of the company. So only 17% of the IT teams can deliver fast enough. Out of 100% IT teams in all the companies in the industry, so there is only 17% of the IT teams are delivering fast. Okay, so what is actually happening? So most of the time, so we'll be spending on testing, deploying, releasing, and then designing and then building it again. Okay, so you're spending more time in testing, deploying, and releasing than designing and building it. So as I told you, okay, so there will be 20 days, 30 days of time, okay, you'll be waiting to deploy. And once the developer develops a new code, he has to send an email to the build and release engineer saying that, okay, so I have committed the code, please make the build. So these guys might be busy, okay, or might the engineer is not available. So some guy comes to the picture in some other time zone, okay, so that guy makes the build, and whenever he feels free, and he will send an email to the QA team. Again, the same thing happens to the QA team. So these guys might be busy with other projects, or the guys are not available. So the teams are there in some other so time zone. So they come in that different time zone. So they test it. Okay, so they take a couple of days, and they say that okay, so we're testing it rigorously. Okay, so even though they have automated testing, okay, so they'll be doing a lot of manual testing, might be. Okay, so a lot of things will be there. So this makes the product functionality a delay. Okay, so and the next one you have is okay, so and also production incident. So whenever you are okay releasing a production environment or releasing a code into the production, there will be a lot of challenges coming into the picture. So what are the one of the challenges? So developer gives you the code which is working in a dev environment which is perfectly fine, and okay, by seeing the dev environment you feel okay, so this is working fine, right? So let me put it into the production. So the application engineer so thought of putting into the production, but it is not working. So what happens all of a sudden? So what happens is basically okay, so the developer has made a lot of changes in the operating system. Usually developers will have root access and administrator access onto the dev environment. So they made a lot of changes in the operating system layer. Okay, so to make this particular feature work, but coming to the production, they don't have access, and even they didn't mention that these changes were made. Even he don't even remember actually. He don't even remember what are the changes he made. He thought of doing some testing and while making the functionality, okay, he made it somehow, okay, but he didn't mention those changes, and in production it was hard. It was not working. So then who is screwed? Application team is screwed. Okay, and you want to engage the okay, so and you want to, and usually the production development production releases happens in offline business. So offline business means sometime in midnight. Okay, So midnight, all of a sudden, engineer is working. So engineers works 24/7, and it is not working. So he has to engage a developer over there, and he is not available. So who will be the will be pinpointed? So application team. So there are a lot of challenges from environment to environment. Okay, so these are the very big situations usually happen. So that's the reason actually they made a 20 days time, 30 days time in the legacy environment to put it into the production. Okay, so and also something like, okay, so operations team, as I told you, okay, so like sysadmin team, so even application developer is trying to do something, and sysadmin he may not be available. Okay, so everyone is not in aligned. Okay, so there are a lot of changes were happening. Now all of a term actually the DevOps came into the picture. Okay, so addressing all these problems. Okay, now what is a DevOps? DevOps is not a technology. Okay, so you have a problem, we have a solution. It's not like a technology basically. Okay, it's only a culture, and this culture is basically comes up with a set of practices. Okay, now what is a kind of practice is basically, okay, so you can say like, okay, so while releasing a production release or making a production release, so you have to put a policy or a practice in such a way that developer also has to be available in that time, or whenever the developer is available you make the release. So which makes your okay job easy, so they can mutually communicate and release the development, or development in the sense make the release, right? So there will be lot of okay, so mutual understanding practices. Okay, so in DevOps, so and also it's not only the teams actually mutually practicing, there will be a lot of tools. Okay, so which helps you in communicating between each other. Okay, so DevOps is basically a tools based approach, so it's all about tools, it's not a technology. Okay, it's not a technology, it has lot of tools where the tools integrate between, okay, so developer and build team. So developer is making a, okay, so putting the code into the repository, and he is manually telling to the build and release team to do the build. So can't, okay, so can't, if developer, okay, so submits the new code, can't the build happen automatically? So you have a lot of technology today. Okay, so can't the build make automatically today? Yes, it is possible. So there are certain tools which helps you in making the build automatically. So that's what happens. And once the build is done, okay, so if build is failure, so you can't make any functionality, some kind of scripting where you automatically send information to the developer that whatever the code you have made, it is ended with these errors. Yes, it is possible. So what is the purpose of build and release team there? If there is any issue, yes, you engage build and release team, so they can help you. But unless if it is a daily job, why do you engage? And why build and release team has to engage a QA team? Can't the test cases can be automated? So QA team does the things manually. So can't those be manual? Can those be automated? Yes, it can be automated. So once the build is released, a QA test cases also will be automatically run and get it published in a website, or send an email to the stakeholders that this okay build has been tested successfully, or if it is failed, it goes back to the developer. Okay, some kind of functionality you can make. So how can you make all these things in a streamline is nothing but you can have a lot of tools in between. So you can use whatever the tool is flexible for your environment or suitable for your environment. You can use such tools over there. And same kind of tools like integrating between QA team to the application team also. Okay, now whenever we go with the DevOps usually, okay, so there are certain times, certain terms or certain practices or certain terms we usually heard in DevOps culture. So one of the one is CI, continuous integration, CD, continuous delivery, CD, continuous deployment, CM, and configuration management. And you have one more CM which is continuous monitoring. So that anyhow happens. So these are the four major terms we usually hear in DevOps culture. Coming to the CI, okay, I'm not going to drive you deep in over here at this point of time. Okay, what is a CI? CI is nothing but integrating. So as I told you, you have an application team, you have a build and release team. So you can use certain tools to integrate the task are the mutual tasks what these guys are doing. Okay, you have certain to integrate the tasks. Okay, so that particular terminology is called as CI, the tools which integrate the common task between two different teams or two different tasks. So that particular kind of tools falls under CI tools, continuous integration. So one of the major tool over here is Jenkins. Okay, Jenkins fall under CI. Okay, so Jenkins is famous because of its open source. Okay, there are other commercial CI tools even available, but most of the people are using Jenkins. Okay, so a lot of advantages whenever you go with so CI. You spend a lot of time in developer has to developer can need not to wait for a build and release engineer to come and make the build and come up with saying this is failed or success or so it does everything automated, and that can be done with the tools which are integrating. So one of the tool, as I mentioned, is Jenkins. And the next one you have is continuous delivery. So what is this continuous delivery? Continuous delivery is not something like you're delivering directly. Okay, continuous delivery is you're making your environment. So as I told you here, you have a lot of environments. So developer makes in dev environment, build and release engineer makes in test it in build environment, and you have QA environment, SIT, system integration test, UAT, user acceptance test, and finally you have prod. You have a lot of environments, right? So your code is working in dev environment. So you put a code into the build or QA servers. It may work or it may not work. Okay, so so delivery is basically you're delivering the code. Okay, so and someone has to be there to accept it, right? You're delivering, but someone has to be there to accept it. So you're making your environment automated in such a way that if the code is coming from dev, it has to get delivered or it has to be accepted the delivery in each and every environment. So making an environment to accept the code whichever is coming. So we usually call it as continuous delivery. Okay, so this particular term is called as delivery. So and some people, so delivery is also considered as, yes, you are delivering. So from dev to QA, so you can even deploy the code. So you're making your environment, you're making an environment to accept the code. See, you might be so thinking that so you make a build in the dev environment. So if you put a simple code or files into the QA environment, it may work, but no, it will not work. Okay, so deploying is something like deploying is not like putting the files from one place to another place. Okay, you copy and put it in another server. It may work. You think that it may work, but it will not work. Okay, there are a lot of things which are with respect to the application, with respect to the operating system, with respect to the network layer. A lot of things will be there. Dependencies with respect to the database even sometimes. So things will not work as we think actually, but we can make it work with the CD tools whatever we have in DevOps. Once you make so your environment in CD, so you can deploy wherever you want. And some people will go to continuous delivery, will approach a continuous delivery, so they can make the environments available as well as they deploy the code into the QA and deploy the code into the SIT and even deploy the code into the UAT after making the environment available, but they will not put the code into the production. So there is some other kind of approach people will follow. Now there is another thing called as continuous deployment. So that word deployment itself will tell you that so deployment is basically you deploy the code wherever you want. And once how it happens is, so CD is very dangerous basically. So once you deploy it, or once a developer actually committed a code, all the way he can see the changes in production. Means developer develops a code, automatically build team build servers makes a build, and then it goes into the QA and it goes into the SIT. If SIT succeeds, it goes to the UAT. If UAT succeeds, it automatically pushes the code to the production. Yes, it also can be automated, But to achieve CD, you should have CI and CD. So CI, continuous integration, plus CD, continuous delivery. So unless and until you have those things, so continuous deployment is not possible, as I already told you. Okay. And so CD is nothing but, okay, so the capability of putting the code directly into the production, but most of the people will not use this unless you are in a kind of e-commerce or .com business. Okay, so that also, okay, so will be a lot of restrictions even in CD, continuous deployment, but usually people follow continuous delivery. Okay, production always will be taken care as a manual part. Okay, so we'll talk those things, okay, so in the course a little bit more. But the next one you have is continuous configuration management. What is configuration management is basically you are making changes, okay, so either to your application or to your operating system. So how do you come to know? You have thousands of servers. If you are doing manually, so you make a mistake. Or even if you are doing manually, so where do you track the changes? Don't have any option to track the changes or to track even the, okay, so you have to spend a lot of time or like what was happened. Okay, so a lot of things are there. So instead, okay, so CM is going to help you what you did yesterday and what we are doing today and what we'll be going to do in the future. Okay, so everything can be tracked, and there are certain tools over here which will help you in configuration management. So DevOps is a culture. Okay, so basically it's not like a plug and play solution. Okay, so you buy in the market and you use it. No, it will not happen that way. So it's always less about what we do and it's more about how do we do it usually. Okay, so as I told you, it's not a plug and play solution. It's not an off-shelf solution that can be just implemented just like that. So tomorrow morning if you want to just make it, no, it's not possible. So it's all about the, okay, it's all about the team transforming from the legacy tools they are using to the DevOps tools. Okay, so some people may say, I'm using this tool from okay, almost 10 years, this tool is working fine. Why do I need to transform? Why do I need to automate it? So my tool is working fine and I'm working on that. So things were happened from the last 10 years, but why do I want to change? There will be people so who usually, okay, so often to transform into DevOps tools. Okay, so some way it is good, okay, so some way it is bad even. Okay, so bad things we'll talk later. Right now it's not a good time to talk bad things. Okay, so finally, as I talked about, DevOps is all about tools. Okay, so you have CI tools, CT tools, CM tools, and let me talk about, let me show you the syllabus actually. So we'll be talking about, okay, so introduction to cloud platform and DevOps. So the same, okay, so DevOps will be talking in little more detailed way of each and every term and things in the first session. Okay, once the class starts, first session would be that one. So almost each and every session will take around 1.5 hours, more than 1.5 hours to 2 hours. Okay, so and the next is going to be AWS cloud. Okay, so I am actually, okay, so going to teach all the topics in a cloud platform. Okay, so we can use it in I'm in my local laptop or in my local server. I can show you the things, but the thing is, okay, if I go and teach you in AWS, it is going to help you in understanding the cloud terms or what is happening. Okay, so whenever you go outside with the DevOps knowledge, you may get a job, but if you go with DevOps plus cloud platform, which is nothing but DevOps plus AWS, that is a huge demand. Okay, and one of the major okay, so major service in cloud computing is compute nodes. Okay, computing, so which is EC2. So we are going to host all our servers in EC2. EC2 and cloud. Okay, AWS EC2. So the next one we are going to talk about in the next session is, okay, so here application and middleware services. What is this application is nothing but, okay, as I talked about, application servers, you have Tomcat, JBoss, WebSphere, WebLogic. Okay, so if you completely talk about those things, it's application engineer talk. We'll not talk about. So we'll have an introduction and we'll see how it is usually works and how do we deploy our own code and test it. Okay, so we'll talk about Tomcat server and even we'll talk about web server. And finally, there are certain requirements usually company require. So how do you integrate your web server with application server? So we'll see that one in this session. The next would be, okay, SVN. So we'll talk about SVN version control one, and the other one is JIT. Okay, so which you have famous nowadays. Okay, GitLab and GitHub. So we'll talk about both the things, and then we'll talk about, okay, so till here actually whatever I was telling you is only to till session 5. Okay, so it's of course it includes in DevOps, but it's only a bits and pieces. You're not actually putting together. So once you enter into session 6, so you'll start feeling the, okay, so the automation, how it can be used, how it can be helpful actually. So how these DevOps can be helpful. Okay, so from here, so we'll talk about Ant and Maven. Ant and Maven is nothing but these build and release guys makes the builds. Okay, so how do they make it? So one of the famous two tools which are widely used in market is Ant and Maven. So you have other tools also, like you can go with a basic compiler, even Java compiler, but okay, you have Ant and Maven out there, so we'll talk about those things. And the next one we'll talk about is, okay, Artifactory tools. Okay, so Artifactory tools is nothing but you are putting your build releases in a version manner. Okay, so to handle that in a version manner, so you'll be having a lot of artifacts like what has been released in this version, okay, certain notes and all. So you have certain tools over there, and out of those tools, so you have Sonatype Nexus is the famous one. So we'll talk about Sona Nexus tool in Artifactory tools. And then we'll talk about Jenkins. So Jenkins will integrate each and every component. Okay, so whatever we have talked over here. So we'll integrate our Sona Nexus into Jenkins. We'll integrate Ant and Maven into Jenkins. We'll integrate JIT into Jenkins. We'll integrate SVN into Jenkins. We can do everything. Okay, so we can integrate Tomcat and, okay, web server also. Okay, so Jenkins, and the counterpart for Jenkins you have is Hudson. Okay, another famous tool. So which Oracle is heading this tool. So Jenkins Jenkins was made by Hudson team only. So the guys came out of Hudson and Hudson development and started a new project which is Jenkins. So even Hudson does the same thing over here. So we'll talk about those tools, that tool also, and we'll talk about Dockers. Okay, so what are Linux containers and what are Dockers, Docker engine, how do you make an image, and so this comes under continuous delivery. Okay, so how do you make your environment available? Okay, so Docker is going to help you over there, and even the Vagrant. So this is mostly used for developers. Okay, mostly used by developers for developing the code and all. Okay, so we'll talk about Vagrant environment with VirtualBox. Okay, so it's nothing but launching the virtual machines in your local desktop. And the next one we have is, okay, so we'll talk about Selenium automation test cases. So we'll integrate this with Jenkins, and we'll see, and we see the things manually how a var file can be tested, and we'll see how it can be tested automatically by integrating with Jenkins. Okay, and then we'll talk about a deployment tool, so which is nothing but Rundeck. So Rundeck is one of the deployment tool which is an open source. So I picked this particular tool to show you how the deployment can be done automatically. Okay, so yeah, so Rundeck is that one. And finally, you have two configuration management tools we're talking about. Okay, so which is Puppet and Ansible. So Puppet is a different model, Ansible is a different model, and even we can go with Chef actually. But to have a Chef, if you need to have a Ruby programming knowledge, so that is getting difficult. So that's the reason. Okay, so I'm picking Puppet and Ansible over here, and even Puppet is more famous than Chef. Okay, at least till now, but Chef is also picking up. But okay, so if you know Puppet, that is one model, and Chef is also the same model, and Ansible it's a different model. So anyhow, if you know two models, that is fine. And finally, we'll go with monitoring. Okay, so the native Linux tools for monitoring, and we'll try to configure and try to do monitoring using a monitoring server, which is Nagios. And finally, we can go with the cloud concept, which is AWS CloudWatch. Okay, for monitoring things. And finally, I'll show you. Okay, so I'll show you a small kind of project. Okay, so how a DevOps environment will be. So this is about my course content. I took more than 30 minutes. Okay, and if you have any questions, you can put through. Anyone.